So now I'm going to explain the n-queen problem. N-queen problem is a special problem where we'll be given an n into n chessboard, and we have to place n queens there so that no two queens attack each other. That means the scenario is like this. If we consider n equals to 4, okay, so we will have n into n chessboard which is like this. Okay, sorry for that. Okay, this is n into n chessboard. Uh, and you have to place four queens such that no two of them attack each other. If you place one queen here, okay, and place another queen here, this will attack each other. So you have to avoid these kind of situations. Okay, so if you place here, this will also attack. Okay, so this type of thing can't happen. So now if we try to, so what queen does first let's see what queen does. Okay, if you don't know what queens attack, well, queens can attack. Suppose it's a 3 into 3. Okay, let's get erase first all these things. Okay, so for suppose this is a little chessboard. Okay, so and then now I will place my queen here where it can attack. It can attack here, it can attack here, it can attack all the places. Okay, so first let's see if we have to check for bigger ones. Okay, so that you could understand easily where it doesn't attack. You have seen where it attacks. That's all. Okay, 1, 2, 3. Okay, suppose if I place my queen here, it can attack where? It can attack diagonally. Okay, diagonally it will attack. It can attack here, it can attack here, it can attack here. All these places it can attack. It can attack here, sidewise. It can attack also up and down. Only these places where I'm putting, okay, I'm marking 0. Only these places queen can't attack. Okay, so we have to do this in this way. Okay, now what is the solution? Can you guess it now? Okay, first try to guess, then I'm giving it. Okay, what is the solution? Okay, the solution is optimal for your n equals to 4, just like this. Okay, 1, 2, 3. If you place a queen here, okay, once this can be done. Okay, if you place a queen here, this is also done. Okay, if you place a queen here, this will also do. If you place a queen here, this will also do. So because this is one solution for integral support. Another one will be its mirror image. It's the opposite one of this. Mirror. We'll talk about more later. But now first we have to find this. Okay, how can I do this? Now I will explain the code from GFG, the where all follows. Okay, it's very simple code. I will explain it to you. Okay, so this is the code I've taken from GFG basically. Okay, and can call it. First, what is this function doing? Now let's start from main. We have given a function solve in queue. Okay, we will basically do our operations in this function. Okay, so first we are making board in queue, initializing it a 4 into 4 0, 4 into 4 chessboard where all the marks are all are 0 marked. Okay, only the places we can place queen will marked as 1. Okay, so now we are passing it to this function solve in queue. Solving it at console, what we are doing is if caller return equals to 1, we are returning true. Oh, column. Okay, first that means if all squares are placed and we are coming again, so it will true. This is obvious. Okay, now we have to go to the main part. We have to see that you have to check if the queen can be placed in board. Okay, first we are passing board our into a chessboard array and first 0 and column. Okay, let's see what is the ECF function doing. An ECF function doing is it is attack utility function to check if a queen can be placed in board row node. This function called column and queens are already placed in 0 to 1, so we need to check only left side of attack position. Hence we have to only check the row on the left side, the diagonal on the left side and the lower diagonal on the left side. Why we'll not check others? Now I first explain that. Okay, because we are placing, suppose it's a backtracking solution. Okay, so we are first placing it on the 0 0. And okay, let's see, we are making it from 0 0, so we are starting it from here. Okay, we will start this from here and it will go on the right side from left to right. Okay, so if we place it and here or here, if we place the second, now when you move to the second column, if we place it in here, we first check that we don't need to check the right side because we are starting from the left only. Now if we check it from here, we will see that on the left side you have to only check the left side and the left diagonal, and if left upper diagonal left level. Because suppose if we place our queen here, then if we place it on here, we can check that this will contradict. Okay, if we place it our queen here, this will also contradict. If we place our queen here, this will also contradict. Only these three you have to check because there is no logic of checking on the other side because we are going from left to right. This is a common doubt for everyone who is trying to solve this problem first time. Okay, why we are checking only these three. Okay, now back to code. Now for checking the row in I if you have placed a certain row, suppose I equals to 0, I less than column, because it's coming from 0 to where we were certainly placed. Okay, now let's see. Let's see. No worry, my friends. Okay, suppose what I'm telling you. Suppose you have placed a queen here. Okay, suppose you have placed a queen here, and now in the second row, I'm trying to place a queen. Suppose queen I have placed it here. Okay, and here I am trying to place another queen. Okay, so the problem will be, you have to see that for I equals to 0 1 2, this is coming that where all these place, if there are any queen available here, our the condition will be filled. Okay, we can't place it here. Okay, Now for the second what is happening key equals to I less than column I j equals to column I greater than 0 j greater than I minus minus j minus minus. So our diagonal, we are checking the upper diagonal now. Checking, okay, no problem. This is where this is from here. Okay, suppose I want to place frequent here. So this is it is in a particular row and column which is here 1 1. Okay, this is 0 0, this is 1 1. Now we have to check from all these sides if there is any queen condition we felt. What is 0 0? It's starting from 0 0, means we are starting it from row and column. It's getting minus minus, so 1 1 1 minus 1 0 1 minus 1. So it has directly reached this, so we have checked it here and it is returning false, so we can place it here. Okay. Now we have to check the lower diagonal of the left side. Okay, lower diagonal, okay, just easy, I plus plus j minus minus. What you have to do in this case, I minus minus j minus minus for upper diagonal, and for lower diagonal I plus plus j minus minus. I plus plus j minus minus, what you will do key I plus plus, we will go for this side, and for j minus minus we will go, I'm sorry, you put I plus plus j minus 1. So what will happen, suppose this is I placed it, this is 1 1. Okay, no problem. And I just, let me remove it. Okay, now let me come to here. If suppose I placed it here in the first case. Okay, now for lower diagonal checking, I plus plus j minus 1. So what is its position? Okay, its position is 2 0. Now if it close I plus plus j minus 1, so it will happen 1 plus 1 1 minus 1, and it will go all these are 2 0. So it will check if 2 0 there is a queen, there is a queen, so it will return false. So we can't place the queen here if it is on here. Okay, this is now it will check. Okay, now we are here. So we have checked that if board I column, if it's safe, we'll place 1 or q the queen as if. Now we are going to, if solving it, now we are sending a recursive function. Okay, board column plus 1, that it will go and check if what it is happening, and if it's happening it will board I column will, it will set as 1. Okay, until I less than n. Okay, when it will go I less than n will complete, it will return true, and we'll come back to our main function. And if it's come true, well, if we're coming true, we'll not go in this function, we just we'll print our solution. If it comes false, we'll print solution doesn't exist. Okay, ठीक. So what's happening, board I column equals to 0 means it will print all others on the solutions 1 and all others 0. Okay, so now I'm going to explain what is happening here in this recursive function. Okay, now just go into my draw board. Okay, so what's happening, okay. First I have placed it 1 here, then I have checked in the second, when I am placing the second, if we place it here, we will check that here this is here, so it will not place here. So if you can place check, can you place it here? No, it will be another diagonal problem. Can you place it here? Okay, so we are going to place it here. Now in this case, can you place it here? Okay, no. Can you place it here? Yes. No, you can place it here because in the left diagonal condition. Can you place it here? No. Can you place it here? No. So this condition is will not happen. Okay, we have to go to more. We have to check another. We have to backtrack. Okay, there is, this is the backtracking condition. 4 dicolumn equals to 0. Now we have to again go to 4 dicolumn equals to 0. Okay. Now we are again here. This is done. This condition is done, so you have to now check it for one. Okay, this is here. Now okay. Now what you gonna do? No, not this. Sorry. If we place it here, now I have to check. This is not here. This is it will not gonna be happening. It will not gonna be happening. It will not gonna be cross out. Okay. Now it's for here. Okay. For third case, can this place here? Yes, it placed here. No problem here. Can you place here on the fourth? No. Can you place it on the fourth? No. Can you place here? Yes. No. This is one solution. Come. Okay. This is how on the recursive will go. If for okay, we'll coming first row, first column will increase it, and at last we'll get our solution. And all the other cases we are setting it 0. The vector case if we see, so all will be 0. Okay, and at last we will print our solution. Okay, that's it. Okay, that's all. And if you like my explanation, please like, subscribe and share. Okay, thank you. See you in next video.